So for these problems we're trying to graph, and we've got a lot of stuff given to us. It's just a matter of kind of interpreting what we're being told. So for this first part right here, this whole line here, this is all from the original function. And what that means is these are points, these are ordered pairs. Put 0 into the original function, we get 2 out. So the graph has a point at 0, 2. Then here we have negative 2 and 2. When we plug those in, we get 0 out. So that gives us 3 points on our graph. Then the next 3 lines here all talk about the derivative of f. So that tells us when graph's increasing, decreasing, where we have minimums and maximums and everything. So this first line tells us that the derivative when x is negative 2, when x is 0, and when x is 2 is 0. So those are our critical values. So we can make a number line for the first derivative. And normally we'd have to find the derivative, set it equal to 0, and solve to find out what numbers to put on this number line, but they're given to us here. Negative 2, 0, and 2. Then, normally, we would go ahead and plug in values in between these values into our derivative function to figure out if the values are positive or negative. Again, it's given to us for this problem. So it's here, it tells us the derivative of f of x is greater than 0. So that means it's positive on this interval when x is between negative 2 and 0. The derivative is positive. Then it tells us that the derivative is less than 0, so negative, when x is less than negative 2, and when x is greater than 0. So that would be both of these intervals. So this is telling us that we're decreasing, then increasing. So at x equals negative 2, we're going to have a minimum point. Then it's increasing, 0, then decreasing. So that means when x is 0, we're going to have a maximum point. Here doesn't change from negative to positive or positive to negative, so we don't have a minimum or a maximum. But most likely it's going to be an inflection point. But to know for sure, we have to look at the second derivative. But I'm going to go ahead and kind of label these off to the side here. That's going to be a minimum. This point is going to be a maximum. Then we need to look at the last part of the data. It talks about the second derivative. So we're going to use that to make a number line for the second derivative. Here it doesn't tell us when the second derivative is 0 like the other one did. So what we have to do is kind of look at these intervals, and it's talking about negative 1, 1, and 2. So those are the values we're going to put on our number line. It says the second derivative is greater than 0, so positive when x is less than negative 1, and when x is between 1 and 2. Second derivative is less than 0, negative, between negative 1 and 1, and when x is greater than 2. Here, the second derivative tells us when it's concave up, concave down. When it changes from concave up to concave down, or concave down to concave up, which it does at all 3 of these points, we have an inflection point. So each of these is an inflection point. And that's where the graph changes from concave up to concave down. So we don't have points on our graph over here where x is negative 1 and x is 1, but we do have one when x is 2. So these ones that aren't graphed on here, we have a little freedom in how we do that. When x is negative 1, it's got to be where x is negative 1, but it also has to be like lower than this y value and higher than this one. It has to be in between there. So we can just go ahead and put it like right in the middle. And at x equals 1, same thing. It has to be between this point and this point. We'll just put it in the middle. Now the thing we have to do now to connect these points and draw the curve is we have to look at these intervals on the number line. We need to see what's going on here. This tells us that it's decreasing to start with, so it's coming down until we get to negative 2. Then it starts to increase. This tells us that it's concave up until we get to -1, until we get to this inflection point. So it's coming down and then going up, and it's concave up that whole time. It's going to look like that to begin with. Then it's concave down from -1 to 1. So from here to here it has to be concave down. Then from 1 to 2, it's concave up. So it opens up a little bit. And then after 2, it's concave down. So our graph should look like that. That's the graph of y equals f of x, our original function.